The GSLV Mark III, the third generation GSLV, inherits various technologies from its predecessors. It's very different in terms of its stages, structure, size, and has double the payload carrying capacity than the Mark II version. Nearly 43.5 meter tall, and with a lift-off mass of 641 tons, ISRO's GSLV Mark III D2 is about to roar once again at the second launch pad at SDSC Shar.
Geosynchronous Satellite Launch Vehicle Mark III is the heaviest launch vehicle of India. GSLV Mark III is capable of lifting up to 4-ton mass to geosynchronous transfer orbit or a 10-ton payload to low Earth orbit. This vehicle is powered by two S200 solid motors, one L110 liquid core stage and a powerful liquid cryogenic stage C25. This mission is second developmental flight of GSLV Mark III, and this is important mission for GSLV Mark III program, as after this success of this mission, GSLV Mark III will be declared as operational and will join the group of operational vehicles PSLV and GSLV. The payload for GSLV Mark III D2 is a very advanced high-throughput satellite GSAT-29, which is a multi-band, multi-beam communication satellite with a lift-off mass of 3.4 ton. GSAT-29 payloads are configured to cater to the communication requirements of users from Jammu and Kashmir and northeastern regions of India. Apart from these operational requirements, the satellite would be demonstrating several new and critical technologies also.
The first stage of this giant vehicle consists of two S200 boosters, which are 26.2 meters long and 3.2 meters in diameter. Each has a capacity of carrying 205 tons of solid propellant. S200 is the third largest solid rocket motor in the world. The L110 core stage carries 116 tons of earth-storable liquid propellant. It is nearly 21.4 meters long and 4 meters in diameter. It employs two enhanced thrust Vikas engines. The 13.5 meter long indigenous C25 cryogenic upper stage forms the third stage of the vehicle. It uses 28.6 tons of supercooled liquid hydrogen and liquid oxygen, which provides more thrust for every kilogram of propellant burned compared to conventional liquid propellants. On top of the third stage is the spacecraft in the 5-meter diameter payload fairing. The first successful experimental flight of GSLV Mark III took place in 2014 when it carried a crew module as its payload. Both its solid and liquid propulsion stages had performed well, and the vehicle was proven in the atmospheric flight regime. The first developmental flight of GSLV Mark III successfully launched India's high-throughput communication satellite, GSAT-19, weighing 3,136 kilograms on 5th June 2017. In this GSLV Mark III D2 mission, the rocket will carry the 3,423 kilogram GSAT-29 communication satellite into geosynchronous transfer orbit. GSAT-29 is a forerunner of future advanced communication satellites of INSAT and GSAT series. Its Ku and Ka band communication payloads are designed to mainly focus on providing high-throughput connectivity to the large population of the country, including the ones in hilly and geographically inaccessible areas of Northeast and Jammu and Kashmir regions. The satellite is also a test laboratory for several new technologies. It is a 3-axis stabilized geostationary satellite configured on ISRO's enhanced I-3K bus. The satellite has a multi-band, multi-beam payload, which is essentially meant for demonstrating new technologies. The Ku band payload of the spacecraft comprises transponders for Northeast and for Jammu and Kashmir regions. The two overlapping spot beams, one each over Northeast and Jammu and Kashmir regions, will provide connectivity between users carrying small terminals. The Ka band payload consists of fixed and steerable beams to serve the country, including the Northeastern and Jammu and Kashmir regions. GSLV Mark III D2 vehicle will lift off with the simultaneous ignition of its S-200 boosters. The ignition of the liquid core stage will be at 114 seconds into the flight. Both the boosters will burn out and separate from the vehicle at 140 seconds after liftoff. At 225 seconds, the payload fairing will separate. At 317 seconds, the liquid core stage will burn out and separate from the vehicle. 2 seconds later, the C-25 stage will ignite and will burn for almost 10 minutes. Subsequently, it will shut down at 965 seconds. GSAT-29 is planned to be injected into a GTO with its perigee at 190 kilometers and apogee at 35,975 kilometers. The Master Control Facility, MCF, at Hassan will take over the command and control of GSAT-29 soon after its separation from GSLV Mark III D2. The satellite orbit will be raised to the final circular geostationary orbit, GSO, by firing liquid apogee motor in stages. Once the satellite reaches its final orbit, the solar panels and telecommunication antennas will be deployed. With the success of this flight, the development phase of GSLV Mark III vehicle program will be completed and the vehicle's operational phase will begin. Thus, GSLV Mark III D2 will be a significant milestone towards achieving self-reliance in space activities.
Good morning to all of you, ladies and gentlemen. My name is Justin Jacob. I'll be your MC for this summit. On behalf of Iesa, I'd like to extend a very warm welcome once again to all of you seated here to the Spacetronics and Deftronics 2019 in collaboration with ISRO and DRDO. Today marks the second edition of Spacetronics. The theme for this summit is Intelligent Electronics, the New Frontier Securing Our Land and Space for both the days. We'd like to welcome you to this inaugural session. As we start with this inaugural session, we begin with a video from ISRO. Could we have the video played, please?
With years of dedicated efforts, today India has operational satellite launch vehicles and has the capability to launch light, medium or heavy satellites weighing up to 4 tons. GSLV Mark II is one of them. GSLV F-11 is the 7th flight of GSLV Mark II and is equipped with the indigenously developed cryogenic upper stage. This 3-stage launch vehicle is 51 meters tall and has a lift-off mass of about 421 tons. It has the capability to launch 2-ton class satellites into geosynchronous transfer orbit. The first core stage of GSLV Mark II consists of an S-139 solid motor and 4 L40 liquid strap-ons. It is 20 meters long and carries 139 tons of composite solid propellant. The strap-on motors are individually 19 meters long and carry 42 tons of earth-storable liquid propellants. The second liquid stage is powered by a high-thrust Vikas liquid engine. It is around 12 meters long and uses earth-storable liquid propellants. The endogenous cryogenic upper stage is the third stage of the vehicle. It is around 9.8 meters long and uses supercooled liquid oxygen and liquid hydrogen propellants. On top of the third stage is the 3.4 meter diameter payload fairing, which encloses the satellite. GSLV F-11 incorporates some major improvements. While the high-thrust Vikas engine in the second stage enhances the vehicle performance, induction of electromechanical actuation system leads to improved reliability. In this mission, the vehicle will launch 2,250 kilogram GSAT-7A communication satellite into geosynchronous transfer orbit. The satellite is configured on the standard I-2K bus with bipropellant chemical propulsion system for orbit raising and in-orbit maintenance. The 4 solar panels are capable of generating around 3.3 kilowatts of electrical power. Ready to be launched from SDSC Shar by GSLV F-11 flight, GSAT-7A satellite will provide a variety of communication services to the nation for years to come. With its passenger satellite GSAT-7A safely mounted in its payload fairing, GSLV Mark II is standing tall, majestically on the second launch pad of the Satish Dhawan Space Center at Sriharikota, waiting to begin its journey.
What a truly inspiring video. Ladies and gentlemen, we are indeed honored and privileged to have with us this morning our first chief guest, Dr. P.V. Venkatakrishnan, Director, CBPO, ISRO. Could we have the introduction video play? I'd like to introduce all of you to him. P.V. Venkatakrishnan is Director, Capacity Building Program Office at ISRO. He's a renowned scientist with 36 plus years of experience in aerospace materials and manufacturing. He has extensively contributed in areas like ceramic and glass ceramics, thermal barrier coatings, and high-end insulation materials. He has played an instrumental role in deployment of liquid propulsion systems and has worked as director at LPSC ISRO. He has headed various divisions within ISRO, and presently he's the director of the Capacity Building Program Office at the ISRO headquarters. Ladies and gentlemen, please give him a huge round of applause as we welcome him to this event. I would like to request Mr. Anil Kumar Muniswamy, past Chairman IESA, to please escort Dr. P.V. Venkatakrishnan onto the stage. We're also honored and privileged to have with us Dr. A.S. Kiran Kumar. Could we play the introduction video, please?
India has duly recognized his contributions. Kiran was conferred Team Achievement Award of International Academy of Astronautics for Cartosat in 2008 and Chandrayaan-1 in 2013. In 2014, he was honored with Padma Shri, country's prestigious civilian award. But the award closest to his heart is the Gandhi Peace Prize, which he accepted on behalf of ISRO in 2014. He was appointed the chairman of the International Committee on Earth Observation Satellites and was also part of the Indo-US Joint Working Group on Civil Space Cooperation.
You know, you and I first had an opportunity to meet in a group called CIAS, the Committee on Earth Observation Satellites. And so for that entire community, it was an absolute joy when we learned that you would become the new chairman of ISRO. And then I understand that as chairman of ISRO, you have really been responsible for what's maybe coined as the new space, and have really taken the Prime Minister's vision and guidance to heart about ensuring that there is no space between space and the common man.
I'm speaking to a chairman of Space Commission, and then asked him, where are you? He told me he is in Ahmedabad. Then I asked him, when will you come and take charge in Bangalore? He told me next day. And I requested him, please come to the National College, as soon as you take charge. He came within about 1 or 2 hours after taking the charge. Such a simple man, such a humble man.
Kiran Kumar took over as chairman of ISRO in 2015. With his calm and composed, ever polite and very modest persona, but a very resolute leadership, ISRO launched 20 missions during 3 years of his tenure, many of which were highly complex.
For a long time it was only one launch a year. Telling about satellite rocket launch. He brought it to around 6 per year.
The remarkable feat of launching as many as 104 satellites in a single mission of PSLV C-37 in 2017 is one such example.
He used to give full freedom for us to carry out the work, what we are planning. That freedom really makes us to work on more and more. That is the one thing. The second characteristic I liked very much was his in-depth review. Very nicely he'll go into the problem, and even the finest question he used to ask. That really was help us to sharpen.
This gentleman taskmaster also propelled the organization towards the realization of technology demonstrators like the reusable launch vehicle, as well as the realization of GSLV Mark III launch vehicle. The constellation of Indian Regional Navigation Satellite System, NAVIC, was also successfully completed under his watchful eyes.
His equanimity, he, in his job, in various stages, he has faced problems. Whether it is success or failure, he is the same person.
He's a very nice, simple, humble person, which he continued all through his life.
Very daring person, but at the same time very, very unassuming.
He doesn't come across as boisterous or loud or obnoxious or, demanding and yelling and screaming, but, this is a rare kind of leadership that I see,
I will describe him in some sense by a description which all of you would probably recognize, namely the curiosity of a child.
So I always used to make a comment to Kiran Kumar, to ISRO. He is like a broad spectrum antibiotic. Any problem, if he is there, he is able to tackle that.
His capability to argue about what he believes or counter-argue what you believe. I always tell him that if he would not have been ISRO, he would have the finest lawyer in the country.
And we all call him 9 Sigma man, okay? He would have talked about 3 Sigma, 6 Sigma. He's a 9 Sigma man. Details are always, eyes for details is very, very important, aspect or characteristics of Kiran Kumar.
Kiran Kumar is an exceptional scientist who, with his visionary ideas and work, has placed India on a high pedestal, shared only by a few nations in the field of observation of Earth from space, navigation, satellite communication, space exploration and space science. Kiran continues to mentor ISRO. He is an inspiration and a beacon for those intending to follow his steps.
He was always definitely, as far as I'm concerned, my role model. I always wanted to, leave home, go experience the world. But he is definitely the main reason I came back to India, because he always spoke very highly about the fact that we should do something for the country.
Tonight, the Aerospace Historical Society, in collaboration with the Graduate Aerospace Laboratories at the California Institute of Technology, honors and recognizes the achievements of A.S. Kiran Kumar, former chairman of ISRO and Secretary, Department of Space, Government of India, with the International Von Karman Wings Award 2018. Aluru Seelan Kiran Kumar, a visionary scientist who has always aimed high and has taken us closer to the stars and heavens while remaining absolutely down to earth. We salute his contributions to humanity.
Ladies and gentlemen, we'd like to extend a very warm welcome this morning to Padma Shri Dr. A.S. Kiran Kumar. I'd like to request Mr. Jitendra Chadha, Senior Director, Operations and Strategic Relations, Intel India, and Chairman IESA, to please escort Dr. A.S. Kiran Kumar onto the stage. I'd like to request Jitendra Chadha to present our chief guests with a bouquet as we welcome them to this event. I'd like to request Mr. Anil Kumar Muniswamy to present a bouquet as we welcome Dr. P.V. Venkatakrishnan, Director CBPO ISRO, to this event. Ladies and gentlemen, before we move into this inaugural session, as it's customary here in India, we will have the ceremonial lighting of the lamp. I'd like to request the dignitaries on stage to please partake in the lighting of the lamp. I'd also like to invite on stage Harrier Marin Martinod, Vice President, Engineering and CTO, TE Connectivity; David Gamba, Senior Director, Aerospace and Defense, Vertical Marketing, Xilinx; Reena Rajan, Vice President and General Manager, Customer Experience Group, Intel Corp; Andrew Glascott Jones, Field Applications Engineer, Teledyne, E2V Semiconductors France; and Rahul Mathur, Director, TE Connectivity India, to please join the dignitaries on stage and partake in the lighting of the lamp. The ceremonial lighting of the lamp by our chief guests. And by the other dignitaries on stage. As we formally inaugurate this two-day summit. That was the ceremonial lighting of the lamp, ladies and gentlemen, like I mentioned earlier, symbolic of the transition into light from darkness. And with that, we have officially inaugurated the two-day summit. We'd like to thank the dignitaries on stage and our guests for partaking in the lighting of the lamp. I'd like to now request Mr. Jitendra Chadha, Senior Director, Operations and Strategic Relations, Intel India, and Chairman IESA, to deliver the welcome address.
I sometimes pinch myself, just to say, just to feel, what have I done to be amongst this, crowd, and especially some of the people sitting on the dais here. But people say I have been lucky, for many, many years now, and I hope this luck keeps riding for me. So I'm not complaining. I'm just pinching myself once again, and saying that I am, part of, this, crowd today, this platform today, and I feel very honored and humbled to be here. Uh, Now, first of all, very good morning and welcome. I know, getting on time, beating the Bangalore crowd in the morning, it's not easy, but it's good to see that we have more than 90% of the people that we were expecting, today here. So, on behalf of Iesa and on behalf of all the tech community that has been part of, organizing this, I welcome all of you here. This is the fifth edition of, now we call it Spacetronics and Deftronics Meet. This started 5 years back as a defense focused or Deftronics meet, but last couple of years we added space to it. Very obvious, because if you really look at the electronics ecosystem and you look at the strategic electronics ecosystem, these two, space and defense are the key components of it. And without these two, I think our strategic electronics would not have been having a complete shape. So adding space to the defense, was the decision taken a couple of years back, and that's how we now have Spacetronics and Deftronics conference going forward. Now, what is this platform? Why do we have all of us come together here? If you really look at all the conversations and the platforms that we have in the country, this is one of the biggest platform that has come together to chart the way for the space and defense, to make the space and defense intelligent through the use of electronics ecosystem. That's the charter we have taken as far as this event or this meet is, or this platform is concerned. Now, as you all know, Iesa has a charter of leading the electronics and semiconductor innovations and ecosystem, taking it forward for India. And we work with we work in the design, we work to promote the design activities in the country. We work on promoting the product development in the country, and then Iesa is very, very eager to make sure that design-led manufacturing takes off in the country in a big manner in the coming years. And the electronics and semiconductor ecosystem is growing at a very, very fast rate over the last 5 to 10 years in the country. Actually, in the last 5 years, if you see the growth rate of electronics and semiconductor industry in the country, it is growing by a CAGR of 20 to 22%, which is by any means great growth rate. Now, you can say we started with a smaller base, so we are growing faster, but we see that this growth would continue in the next 5 to 10 years. Now, if this growth has to continue at 20 to 25% rate, strategic electronics can't be left out of that growth. So if the last 5 years, if the growth has been 20-25%, I think strategic electronics has been little lower than overall electronics and semiconductor growth in the country. So one of the challenge that we have and one of the opportunities I would say we have is, how do we bring the strategic electronics growth at par with what is happening in normal electronics growth or electronics and semiconductor growth in the country. So that is basically a good challenge to have. So overall industry, that's a good challenge, but for our space and defense programs, that is one of the major strategic ask going forward. Now, I'm not a expert on it, so the experts will come and talk on it, but if you look at everything that is going on in the space and electronics and space and defense space, the electronics in the next 8 to 10 years would have a portion of 40 to 40 to 45% of components, electronics in the platforms that space and defense has. So today I exactly don't know the number because this number varies from 10 to 15%, but look at the leap from where it would go. Even if it is 10%, take the leap of 10 going to 40% in the next 8 to 10 years. So there is a great challenge for all of us as the electronics and semiconductor companies or organizations, but it's a great opportunity to see forward and what we can do in the coming years. So I'll not take much time, but here are my thoughts that I think we can do something because it's a big challenge, it's a big opportunity. We need to take some bigger steps. Couple of things that I think we need to think about and talk about. The number one is how can we create a very robust infrastructure for electronics and semiconductors for space and defense, uh, uh, for space and defense capabilities. And when I say the infrastructure, this is about how can the designs be done locally out of India, how can some of the manufacturing infrastructure can be set in India. I think without creating a very robust platform as far as infrastructure is concerned, I think we may be we may lag behind in this space. So the number one we have to think about is how a great infrastructure can be created for strategic electronics for space and defense in India. Number two, I think there is a good opportunity. We talk about just meeting the local needs at times, but I think this is one area, strategic electronics, where we can actually leapfrog as far as India's position in the world is concerned. Today, if we are, at times dependent or having a lot of partners from global partners, which should continue, but I think we should become the strategic electronic suppliers to the global partners. It's whereas we are today maybe an importer of a lot of technology, but strategic electronics can become strategic advantage for us to leapfrog and become a supplier for the world. That's number two, I would say, the challenge we should take. Number three, when I was just roaming around and talking to a few people before we came into the room, I think we are missing the participation of youth in this dialogue today. If you really want to make this a strategic investments for India in the future, if we want to make strategic electronics as a strategic capability for India in the future, I think we need to bring in the youth to participate right from now so that we have a great pipeline of people who can take this charter forward. I think we all are very passionate about this, and we will work on it very hard, but we will only take it that far. I don't think I will be having as much as energy 10 years from now. I would really like to bring in youth to come in and be participative in this. And maybe we should have something, space and defense for youth program, started. And I am actually taking a challenge and giving a challenge to Iesa. I know a lot of executive committee members are sitting in the room here. Can we take the challenge of bringing in, youth in this space? So I'll leave with my thoughts on what dialogue or what kind of things we can do to create a great infrastructure for strategic electronics in the country. Can we take a goal of leapfrogging and becoming a supplier of strategic electronics to the world? And one of the things we need to do is to bring in the youth in this dialogue and participation. So with that, I think the next 2 days I'm looking forward to participating and hearing what experts have to say. We have 30 startups that are going to display their solutions and products. So please go and visit their booths and have an interaction with them. There would be experts that are here. We should have a great dialogue with them. And out of these two things, I hope we can come out with at least 3 to 4 very big strategic initiatives that we can take together as an industry, as an organizations like ISRO and DRDO, and together work towards, meeting those goals. So with that, I hope we all enjoyed the next 2 days, and I'm looking forward to interactions with you. So thank you and welcome.
Thank you very much indeed, Jitendra, for the welcome address and setting the tone for the summit. I'd like to now request our chief guest, Dr. A.S. Kiran Kumar, scientist and former chairman ISRO, to deliver the theme address.
Good morning to all of you, dignitaries on the dais, and members of the Iesa, and all the participants of this two-day event, where Iesa is trying to bring in both the space segment and the defense segment into focus and look at what can be done and how we can move ahead. As you have been seeing, that India is making rapid strides in the space activities, where space is becoming a new frontier, and space as a new frontier is attracting the attention of a large number of entrepreneurs across the globe. And today you are seeing there are many companies which are actually ferrying cargo to space station or looking at carrying humans to planetary bodies. And we in India, as you have seen, are making rapid strides, and with the successful launch of Chandrayaan-2 as well as the GSLV Mark III third mission successfully completed. And in the last couple of years, we have made very significant progress, wherein we have brought in many new capabilities of observing Earth in hyperspectral imaging, or making use of K-band and even optical communication systems between geostationary platform and Earth. And in all this, we are also looking at how we can actually engage more and more the industry. You will hear probably more of it from Dr. Venkatakrishnan, who has been entrusted with the responsibility of ensuring that Indian industry is enabled not only to meet the demands of ISRO, but also to make sure that they are capable of contributing to the global space activity. Now, in terms of the electronic systems itself, what we are looking at, while you saw the couple of videos showcasing the huge structures, apart from a lot of chemicals and then the propulsion system and the huge massive mechanical systems there, the heart of many of these systems actually lies in electronics. And today you will also be happy to know that in Chandigarh we have a center where we are actually bringing out chips which are required for which does the job of controlling the launch vehicle's trajectory and the complete operation, the processor chip, which we call as the Vikram processor, and also many of the chips required for our radar imaging satellites, and which are progressively being put into operations. Not only that, this foundry is trying to enhance its capability not only in the area of only silicon, but also looking at the possibility of using silicon germanium, and also trying to make use of MEMS capability that is there. And in the recent missions, we have actually flown some very advanced sensors, whether it is the laser gyro systems or the servo accelerometers, which enabled us to actually ferry the lander right very close to moon, and we fell short by a few, you can say 100 meters before it touched down. One of the key things is in this, there are also a couple of instruments which are extremely, you can say, capable. While Chandrayaan-1 enabled us to look at water, availability of water on the moon and presence of water molecules and OH molecules In Chandrayaan 1, we had carried instruments which were from USA, what was called the M-Cube or Moon Mineralogy Mapper, and a mini SAR, whereas in Chandrayaan 2 orbiter, we have advanced and improved versions of this. One of them is called the spectrometer, IARS, that imaging spectrometer. Another is a dual frequency SAR, synthetic aperture radar. In fact, dual frequency synthetic aperture radar is a very novel development which enables us to look at the permanently shadowed regions on the moon and actually unambiguously detect presence of water ice and also map the entire moon. The same development, actually the point of telling is, earlier for example when we were doing this SAR development, the interaction between ISRO and NASA, today we have a program called NASA ISRO Synthetic Aperture Radar, where we are collaborating together, and by 2021 the launch of this satellite will enable mapping of the entire Earth to few centimeter level variations on the surface it can detect. Today ISRO also has come out with an X-band SAR which is about 5 to 6 kg in weight, which can be flown on either drones or on the aircrafts. While all this development has been happening, it's also the endeavor of ISRO to make these technologies available to the industry, and industry can really make use of it and build their own systems around that and provide not only in the area of synthetic aperture radar, altimeters, or in fact even hyperspectral instrument. You will be happy to know that it was only a company in Bombay which provided the key components of this instrument, which today is operating on Chandrayaan 2 in a very successful manner. And this particular gratings, a specific fabrication technique which was adopted and provided by the Indian industry. So in the same manner today, if you look at whether it's our NAVIC system or the communication systems which are growing, whether it's GSAT 11 or in the coming days you will have very large high throughput capacity coming up. All of this requires significant amount of electronic subsystems and systems to be realized, and today we still depend largely on international sources for many of the communication equipment. And not only that, in terms of geospatial technology, usage of NAVIC, and already some of the one mobile company has already brought out on a mobile the capability of using the NAVIC enabled signals and provide geospatial solutions. As you may be aware, today any aircraft which is going to be registered in India from January of this year is required to carry the Gagan enabled receiver, so that both en route planning as well as precision landing it can help. In the same way, in the coming years, use of NAVIC is going to enhance significantly, and the messaging capability in this NAVIC is providing to the fishermen a unique solution. Today there are a couple of companies which are producing small gadgets which are being fitted into the boats of the fishermen, and using the mobile of the fisherman just as a display device, he is able to see on his mobile in a form of a video compass where to go for fishing, that is prospective fishing information. And not only that, in his mother tongue he is getting alerts about the weather vagaries that are going to occur in the coming days, or if he is crossing the international boundary. And NAVIC also has a unique messaging capability which can make a big impact in Internet of Things, and connecting to remote places for commanding is a possibility. So the opportunities are many, but if you look at as the country is progressing today, more and more opportunities are being provided, and the government is also looking at how India can become self-reliant in the area of electronic subsystems and components, where in the coming years it said that it's more than $200 billion the actually import that is going to occur. If we have to make a huge impact in that, it is like what Jitendra said, it is for our next generation to really capitalize on the opportunities available. And as he really pointed out, the youthful dividend of the country, if it has to make an impact, we need to encourage more and more of them. And I am extremely happy to see that this particular event is actually bringing to focus about 30 startups and then providing them opportunity to showcase what they are doing. It's only when we do more and more of this, provide more opportunities to them, and also help them in succeeding, that we can not only capture the market within the country, but also capture substantial portion of the international market. And it is here that associations like this can make a huge difference. I would like to call upon them to look at ways and means by which they can enable the next set of entrepreneurs to actually look at newer opportunities of making use of electronics, which is, as you are aware, is the heart of any intelligent processing system. And with the today's AI, machine learning, and the likes of using intelligence to solve the problems is becoming more and more order of the day. It's only when we enable them by providing appropriate opportunities, by, like what was said, setting up the infrastructure in the country which makes use of that. Today, while the Indian intellectual mind is actually doing the value addition across the globe, the value addition in the chains, where the chains have been set up by our friends across the globe. It's only when we ourselves establish this chain that we can really take the advantage of the true intellectual capability of the Indian minds. And it's a challenge to this association to make sure that we have in the coming years the intrinsic capability to develop, build, and then harness the capability that exists in the country. So in the end, let me take this opportunity to compliment Iesa for bringing together a set of new entrepreneurs and then showcasing to them what exists, and also challenging the entrepreneurs here to make their impact not only within the country and globally. Wishing 2 days of intense deliberations for you, and thank you very much.
Thank you very much indeed, Dr. Kiran Kumar, for the theme address and for those encouraging words. I'd like to now request our chief guest, Dr. P.V. Venkatakrishnan, Director, CBPO, ISRO, to address the gathering.
Very good morning to all of you. A warm welcome for this 2 days function. In fact, I was just listening to my mentor and boss speech. He has taken in a capsule form what exactly has happened in the past, what we are doing in the present, what is required for the future. Of course, my dealing will be in a different terrain actually. I'm a in and out industry man. I am not an industrialist, but I am known as an industry man in ISRO. My challenges are different, and my whatever thought process I am having in my mind is totally different actually. Would like to share with you some of them at least. I was just thinking why 2 lamps are there today morning. I never come across so far. Only 1 lamp so far. So I was just thinking, if I got more space, you can accommodate more people. Okay. I used to wonder sometimes, if you want to accommodate more people, you used to put more wicks and all. The guided path for the wick will not be there. Be a plain one. Be crowding the wicks. So many things. What is wrong with going for 2 or 3 lamps now? Nothing wrong. So there are ways of doing things. We need not go through the beaten track at all. Totally different way we can think and we can innovate many things in life. This is one among them. So coming to your domain, electronics, if you really look into the fact that from ISRO, where we started around 50 years back, the entire activities of space activities in this country. The latest entry into industry is electronics. For some reason, it is your own fault actually. Your means okay. Domain. I mean the electronics expert people, which includes the domain which is having in ISRO as well as you all put together. The superset I'm taking and telling you, it was your problem because you thought that nobody else can do it. You are see if you take electronics for one reason. If you really want to actuate an actuator, there is a software part which is resident in the memory of electronic chips, which is being used for giving the commands through the electronic system to the actuator. The actuator itself is a mechanical part. And there are control electronics, embedded electronics in the actuator itself, not in the actuator arm itself. We are nowadays embedding the electronic to see that space is saved and footprint is saved. Lot of integrations come into picture. Sometime back, a separate branch called mechatronics evolved. I remember there was a lot of huge rush for that particular course, but not many were offering that. Only few select institutes were offering that. For that also, so much of rush was there. Then I don't know what happened to that particular branch, not exactly blossomed to the way in which it was supposed to blossom for some reason or other. So all these shows that intelligent electronics, I was just thinking the word itself. If it is, I would like to call it smart electronics because intelligence means no. That system itself should be able to produce another humanoid or another software by itself. Then only it can be intelligent. We are only imparting part of our intelligence to that and calling it intelligent. Means that is not right. It should be able to generate more intelligent siblings or progeny. All these things should be there. Then only it's intelligent. So, really speaking, in the true sense, we can't call anybody intelligent other than human beings. For example, if Chandrayaan-2 itself, somebody was there, we could have saved the lander inside that. Because there was nobody to control there was an embedded electronics, embedded software into that. For that, these extreme conditions were not taught. So it going beyond the limits of your whatever fed into that, it can't handle. But we people can handle that situations very well. We are taken to extremities. We are going to UK tomorrow, means extreme conditions. You are carrying your all woolen clothes or thermal wear. The simplest example I'm giving you. And you go to a summer place, you have summer clothing and all. So, but if it is fed into a system, that also will carry. But not beyond that. If it is rainy season, is not fed into that, you won't carry an umbrella. You will drench. So, in the true sense, intelligent electronics is never existing, but it can be an aim. It can be an apex aim for that. We can aim for that. So you have a lot of way to travel to reach that real intelligent electronics. The challenge is too much. The challenge is too much. It's unlimited. If the system created is becoming as intelligent as you are, then only you can call it an intelligent system. So, long way to tread. So, electronics people, I used to always think that space required for you is very less. But all capital intensive things. And as you can come back to ISRO again, space, connecting to space again, I told some time back that the electronics area was the latest entry into the industry area. We started getting around 10 years back only, a decade back only, electronics industries roped into space systems and space manufacturing. That is because of two reasons. Our own electronics people thought that nobody else can do it outside. We used to wonder, sometimes there was some kind of sarcastic comment from even our leaders saying that, did you study in a different college than the other person who was studied from outside? If you have not studied separately, then okay, he also can do it. But there was not much of confidence. You know, there are a lot of things introduced late of late. For example, I tell you, plus sign is to go to the actuator to the right, minus for left. If you connect wrongly, the plus will go to left. Your vehicle will go to left. Such a small error if it is made. So once it happened, and we have got a sign check now. We got a sign check. There is somebody going there and doing the sign check physically. That plus is connected to plus only. When plus is given, goes right only. Then again, a human being is coming into picture. It is not intelligent itself. Because somebody does connections wrongly, it can go other way. So how can be intelligent then? So there are a lot of things that is still to be addressed and to be rectified to the extent possible when you come to the actual electronics and intelligence system. Then come to the actual arena right now, where we are now coming to the real crux of the problem. We have a lot of industries who want to do actually what they are doing right now in multiple numbers. Last time we had Spacetronics, and we had a lot of discussion after that also. A few months continuously we had ISRO's policy always has been to see 3 C's: connect with the industry. We need to take the lead role to connect with the industry. You need not come to us, we will come to you. And continuity. Once you are connected, we will offer you continuity and cooperation and collaboration from our side, and you become an equal partner. You know, some of the industries today can walk into ISRO headquarters or ISRO system, and they can even take the command that, sir, what you are doing is wrong. This is the way to do it. We give that much of freedom to them because they become equal partners to us. 16,000 employees are there in ISRO, all across ISRO centers, all put across from Ahmedabad to Sriharikota or Mahendragiri down south. If you look at, more than 2 lakh people are working for ISRO. The rest of the people come from the industry. So you are a main partner to us. The least contributing industry sector, if you take chemical, mechanical, material, all put together, is today also continue to be electronics, to my surprise. Because of 2 reasons: we were also not attracting you, you were also not coming to us. So now it is happening now. Last few years, we have taken an extra initiative to see that more of electronics industries are opted into. Now the entire years PSLV is going into industry. You must have read from the news and all now. Entire vehicle, PSLV, 40 plus launches we had. They become the stabilized launch vehicle now. And if you follow the process, anybody can do it in India. Now we are slowly moving into industry totally, so that we can concentrate on R&D and development of newer vehicles and satellites and other systems. So if you really want to equip the industries to see that the integration, the actual whatever work what we are doing in ISRO right now is to be done by industry, we need to equip them, we have to handhold them. All these things need to happen. That is something with technology transfer, what we are having, we are just transferring to you. Apart from that, another area where we need to focus is that today also in India, electronics happen to be a important assemble area. Just import and assemble it and test it in India. Screening. One more screening we are doing. We are importing. One more screening we are doing. We are assembling it in India. Now all assemblage we are doing it in India and testing it. So the components manufacturing still we are importing right now. There are 2 reasons. Yesterday also there was a debate in some other fora here in Bombay or somewhere, where there was a question that how to keep MSME updated. Because electronics is one area where you think today to invest, if you delay it by little bit, thinking that whether I need to invest or not, by the time it becomes obsolete. If you think too much, it becomes obsolete. Okay, that is one area. Okay, you go the other way. You invest now, start doing it. Next day it becomes obsolete. So either way, it is one of the fastest growing and moving industry, cyber electronics, software area and all other things. So keeping updated with the pace of what happens in the rest of the world is very important to remain relevant in this area for you also. All the more important in electronics compared to other areas, because obsolescence is much more happening fast in electronics area. So you should not think much to invest. That is one. If you compare both the options, what is given, delayed investment and investment today, I always prefer investment today. So don't think too much, and think that you start and keep updated. One area in which the MSM is lacking is in updation. I've found that most of the MSs continue to do the same thing what they have been doing some time back. If you just go across and take a survey of things, what is happening in India, at least in India, I don't know much about other countries, but MSMEs continue to do the same work what they have been doing in the past. They don't keep updated because they don't get an option. And after sometimes survival becomes very, very difficult. So there are destructive technologies coming into picture. So the technological updates are happening. If you don't remain updated, your relevance will be questioned tomorrow. So it is in the interest of the MSMEs to see that they form an association, and they should be having in a school, they should be having an updation school like CME in medical education and all, continued medical education and all. You should be having separate forum for you to see that, a weekly forum wherein you have to invest some time for that. If you say that I can't come for this kind of whatever updation classes and all, you yourself are going to be not benefited. So you need to see that your own MSMEs come into collaborate and cooperate each other, call experts from other areas. It's happening now in a random fashion, not in a structured way. So I urge this association to take a lead role to see that you have a continuing education updation classes, and the technology updates are brought in. The kind of impact, if you don't get updated, what will happen? The impact study also need to be addressed properly. If you see 3D printing technology is coming into picture right now, for example, the 3D printing has gone into a long way, and see that your foundry is in danger now. Foundry industry is in danger now because of all these things. And 3D printing is becoming because the products are all becoming almost joinless. Am I right? They're seamless. It's only monolithic and integral. So joints are less. It is affecting the welding industry in a different way. Joining is not coming nowadays. So I was just attending to a welding industry seminar 2 days back in Mumbai. They were worried about somebody always thinking about even the welding expert itself is thinking about jointless product. And I thought you are countering your own your domain, I thought, because he's only able to get 30% efficiency of the weld. If the parent metal 30% efficiency of the weld is only coming, you need to have the enhancement of the joint there to give the compensation for the weld efficiency loss. Then the inert mass is going up. We also go for jointless because welding is coming means their efficiency is less. You need to thicken that area. So payload, inert mass is coming down and my payload is coming down. So a welding expert thinking of jointless, you are axing your own branch on which you are sitting. So you need to stay relevant, means you have to see that what is the way of enhancing. The best way of doing thing is joining only. Because instead of going for a very, very complicated configuration and a monolithic fashion, you can always go for different things and join it. That's the easiest way of doing things. You can subcontract, sub-assemblies, you can always, that is the way of doing things parallelly, and whatever way you can do it faster. But you need to have efficient joining process. Instead of thinking to improve the efficiency of the joining process, if you think of monolithic things, you are axing your branch you are sitting. So you need to focus on things what is relevant to you as a domain expert. Think in that kind of lines and see what best you can do for all these things. So in space, we are having a lot of programs for you. There is one on the annual actually. We are waiting for Kiran Kumar sir to, because he is the person who is clearing all our programs for future. There is one space entrepreneurship and encouragement development program SEED, wherein which we are trying to see that at least 5 to 6 startups in electronics as well as other areas, not electronics alone, all areas put together. Some 6 startups are being funded by us in a phased manner. Money from government will not flow to you just like that. You must understand. There is with some toil and hard work only you can get money from government. Department rules are like that. So we can only give you seed money. From that you have to prove your metal that I am worth getting some more money from you. Then in phases you will be encouraged and developed. Once you are through, then I think you can only tell about success stories like our partner to ISRO. So there are a lot of programs on the annual like this. We are going to conduct another space startup alone. I am contemplating that maybe in the later part of this year or on the initial quarter of next year, we'll be having some kind of startup mela for space alone for all other domains, including electronics, that also we are having. So there is a focus now from the central government as well as department to see that from the Make in India process itself. And just one more point I just want to make it to you. Unless startups are coming, you can't talk about this one job and other things. No, you can your future generation becoming jobless, all these things. Unless startups, some of the students who are coming out, passing out, they don't think of startups, then everybody are ending up in job seekers. Just think that when I was studying in my Kerala, no, I belong to Kerala and I studied there. 6 engineering colleges are there. 135 are there. So we churn out around 130 lakhs of students in different branches today, and everybody is ending up with a job seeker, not a job provider. At least some of them. You can't turn the table at all. The story will continue to you can extrapolate and see what will happen in future. So if you want to see that you have startups. Another one is investment is one is in the form of startups or augmentation, or you can merge and amalgamate, or collaboration like MNCs, or FDI, foreign direct investment, also coming to India. FDI, for that matter, one point I just want to tell you. Unless you consume some of their products in India, a good market is there for their product in India, no FDI is going to come to India. For example, I'll tell you, many of the FDIs are going to, many of the foreign companies are going to China investing there. I just asked them what is happening. Proximity wise, India is also very close. Why can't you come here? Sir, what is that advantage I'm getting? I'm leaving my Germany or Europe or somewhere, my comfort zone, and coming here and investing and doing something here. I can understand that I can get the advantage of cheap labor here, understand. But if I want to sell that product in India, no market here. I need to again export from a foreign country. Exporting from a foreign land to some other land is difficult than exporting from his own land. So he will always, so why you are going to China? China is consuming 2,000 units of my product per year. Then what we are consuming of that product, I'm not aiming that product and company here, not good for, actually I'm not from the point of view of that, but I just want to give an example to you. We are only consuming 135 units. So if you don't consume that capital equipment here, that means numbers, FDIs are very difficult to come to India. Even if you ease out your rules and regulations and one single window, so many things and all, we are not going to come because we don't produce a market here. So industrialization is a must. How the industrialization comes? Just by the giants who are here right now augmenting will not industry. It is only a startups. The startup culture has to come. More number of students have to pitch in. More number of people have to nucleate. Survival is very difficult. You know the kind of curve for startups and all. No? That curve is very famous. Sustaining the client. So many things are there in that. Like any other business cycle. But we'll be, for example, many of the departments are now having startup programs, hand-holding programs. You'll be guided properly, and you'll be through. I don't that you'll be having any difficult problems in the past, in the present compared to the past, because more number of departments are being encouraged to come with startup programs and other things for different domains and so on. So that are all coming now. So unless some of the startups are coming, you start consuming more equipments in India. Leapfrogging also is very difficult, because if you want to really have, see, many of the equipments are very prohibitively costly, because, for example, if you want to get ASIC foundry that for our CL itself, 1800 crores for 180 nanometer. Today is 5 nanometer, 30 nanometer. If you want to outdated one, if you want to get also 1800 crores. So who can afford it? No MSME, nobody can afford all these things. So certain areas government has to invest. Like for example, if you want to have a fab lab, we have to invest. Some people are telling, sir, we want to test it. Where we want to test it? I can do things, but where I can test it? I can't use my main fab line in my CL because it will get contaminated. So you need to have a separate fabrication testing, you can call it a pioneer lab or something like that, to see that you are having a kind of testing line alone separately, even if it get contaminated, does not the main line. So, but that's 100 crores investment. Who will invest? MSME will not invest, because they are ready to invest on the actual thing, but not testing labs and all. So certain kitchens are to be created. Certain kitchens are to be created in India for our own comfort zone. Let us not look into where we are going to break even, where you are going to get return of investment, all these things, because getting food from the nearest hotel is almost easy every day, but you can't do it every day because your stomach will get upset. Irrespective of whether you spend more or less, you always cook in your home. Am I right? So all these things are examples for us. We need to see that we are self-reliant, we are not dependent. Even many of the things are being dumped to India. We get most of the electronic products for a lower cost than what we are going to produce right now. That is one inhibiting factor to see that we are not producing India. Audit queries will come to you. Why are you producing costly things in India when things are available from the outer market on a lower cost? So government has to aid that. If you really want to self-reliant, some things will be costly because you are competing with a giant who was established in that area in a global market for quite long time. You are starting now. Your cost will be always high. Somebody need to understand that. So all these rules and regulations are to be changed if you really want to get a head start in this area. We are working on that. We are trying to educate and our own counterparts in the audit and all the other people that, sir, if you really want to make it in India at this stage and make inroads in the export market outside, it's very, very difficult because we are playing with established giants, monopolistic giants. So if you really want to look into all these things, there are loads and regulations to be changed, accounting rules are to be changed, all these things have to happen in a time frame in next 5 years. If you really think of all these rules and regulations now also, as I told, you will lose the time. You will never catch the running bus. Always be running behind the bus because your area is very fast developing and it becomes obsolete in no time. So we need to have a comprehensive package of things to happen. If these things are to happen in India in a very, very systematic and structured way, rules are to be changed, encouragement has to come, irrespective of the cost factor, if you want to be self-reliant, self-sufficient, and make all these things in India itself. Make in India, nobody has told it should be cheaper or costly. It's only make in India. Think in that way. Don't think of cost aspects of whether importing is cheaper or make in India is costlier. The theme is make in India only. Don't bring in cost factor into that. This I am telling government, not to you. Okay? If that has to be relevant and has to be fruitful and has to be successful. So with this thought-provoking words, I think some of my thoughts I just shared with you. A lot more need to be, I don't want to go into more of because we will be running away from time, and I wish this industry deliberates in this direction also in the next 2 days, how to promote entrepreneurship, startups, and creating facilities. If not individually by you, you can form an association, you can invest together and have labs and continuing education programs and all. Some of your capital can be earmarked for R&D also. R&D has to come from you only. It should not come from outside. We should not be actually a follower of what is happening outside. In certain areas, we need to be the forerunner. For that, somewhere you have to think differently, somewhere you have to start. I think this last 2 years, this starting has happened, and this coming year also, this 2 days also, you think in that direction. If you are able to go with an enlightenment idea of all these things and with vibrancy and vigor from here, at least for some time to sustain, I think this conference has done its job. It has it's met its objective. I wish you all the very best in the coming 2 years of good deliberations and good outcome and good output, and wish you all the very best, and Jai Hind.
I'd like to thank Dr. P.V. Venkatakrishnan for sharing his thoughts and perspectives. Thank you very much, sir. We've almost come to the end of the inaugural session. I would like to request Mr. Jitendra Chadha to present a small token of our appreciation to our chief guest, Dr. A.S. Kiran Kumar. Ladies and gentlemen, please give him a big round of applause once again. We'd like to thank you, sir, for having taken time out from your busy schedule and being with us today. I'd like to request Mr. Anil Kumar Muniswamy to present a small token of our appreciation to our chief guest, Dr. P.V. Venkatakrishnan. On behalf of IESA, sir, we'd like to once again thank you for having accepted our invitation and for gracing this occasion. Well, ladies and gentlemen, as many of you might know, the IESA Spacetronics and Deftronics 2019 awards will be announced this evening. But we very strongly felt that this next award couldn't wait for evening, and we'll be presenting it shortly. I'd like to request the team to please play the video.
India's heaviest launch vehicle GSLV Mark III will launch the prestigious Chandrayaan-2. Chandrayaan-2 is the next leap in technology as we attempt to soft land close to South Pole of Moon. The soft landing is extremely complex and we will experience approximately 15 minutes of terror.
After the grand success of India's first successful mission to Moon, Chandrayaan-1, India's Chandrayaan-2 is all set to be launched by ISRO in July 2019 using GSLV Mark III M1 launch vehicle. This three-stage rocket is the heaviest vehicle built by ISRO and has been selected for India's prestigious moon mission due to its reliability, versatility and payload carrying capability of 4,000 kg. Weighing around 3,850 kilograms, Chandrayaan-2 has three modules: the orbiter, the lander named Vikram, and the rover named Pragyan. Once in lunar orbit, Chandrayaan will deploy Vikram, which will make precise, safe, and soft landing on the moon by September 2019. On landing, the rover Pragyan will deploy to perform mobility and scientific experiments on the lunar surface. The rocket will inject Chandrayaan-2 in the 170 by more than 38,500 kilometers Earth orbit. Subsequently, following a phased maneuver of 5 Earth burns, its orbit will be raised to 105,292 kilometers. The spacecraft will then be nudged into the lunar transfer trajectory. From here, the Chandrayaan will take few days to arrive in proximity of the moon. The spacecraft's liquid apogee motor will be retrofired to insert it into a lunar orbit. Gradually, over a few days, the spacecraft will be brought closer to the moon in 100 by 100 kilometer circular orbit through 5 lunar burns. While the orbiter will continue in this orbit, Vikram will separate and deboost to 100 by 30 kilometers lunar orbit, where it will remain for 4 days. On the 4th day, Optical High Resolution Camera Payload OHRC onboard orbiter will be turned on to scout for a suitable landing site in the lunar South Pole region. The images taken will be transmitted to Earth and processed, after which the landing site map will be uploaded in Vikram prior to its powered descent phase. Lander will hover at 100 meters above the lunar surface and gradually begin its descent. Once Vikram lands, the rover Pragyan will deploy. The payloads of Pragyan and Vikram will then be turned on and start collecting information on lunar topography, mineralogy, elemental abundance, lunar exosphere, and signatures of hydroxyl ions and water ice. The mission life of orbiter is 1 year, and that of Vikram and Pragyan will be 1 lunar day, which approximately equals 14 Earth days. Chandrayaan-2 will attempt to answer questions on yet unexplored lunar surface and open up possibilities of using the moon as a platform for further exploration of the solar system and beyond. With this, India reiterates its prowess in space technology and its commitment to humanity.
Well, ladies and gentlemen, the Dr. APJ Abdul Kalam Award Lifetime Achievement goes to Dr. K. Sivan, Chairman, ISRO. Please give him a huge round of applause. And while Dr. K. Sivan has accepted the award, unfortunately, due to prior commitments, he was not able to make it today. He has sent a letter. It's being projected up on the screen. For those of you seated behind, I'll just read it out to you. Dear Shri Rajesh Mishra, kind reference is invited to your communication dated. I am happy to note that I have been adjudged the winner of the prestigious Dr. APJ Abdul Kalam Award by IESA Spacetronics and Devtronics 2019. I thank the members on the selection panel for this honor. I would have been glad to receive this award in person on September 19th, 2019 at the IESA Spacetronics and Devtronics 2019 summit hosted at the Taj with Yashwantpur, but as I will be away from Bangalore on the 19th, I'm unable to do so. However, Dr. Venkatakrishnan, PV Director, Capacity Building Program Office, ISRO Headquarters, will receive the award on my behalf. So having said that, I would like to request Dr. PV Venkatakrishnan, Director, CBPO, ISRO, to please come up on stage and receive the award on behalf of Dr. K. Sivan, Chairman, ISRO. I would like to request Anil and Jitendra to please come forward and present the shawl and the award respectively. Ladies and gentlemen, please give him a big round of applause, though he is not here with us. He is the recipient of the Dr. APJ Abdul Kalam Award Lifetime Achievement, the IESA Spacetronics and Devtronics 2019 Award. He is the project head of the Chandrayaan-2 mission. I'm told there were over 700 scientists that were part of the Chandrayaan-2 mission. And I think they've made us all incredibly proud. I'd like to request all of you to please give him a standing ovation as this award is not only received by Dr. K. Sivan, but goes to every single scientist, every single member of the team at ISRO, part of the Chandrayaan-2 mission. I'd like to request Dr. P.V. Venkatakrishnan to say a few words on this occasion.
Dr. Shivan was so much happy, and I was to come here today actually. The Chandrayaan-2 mission failure committee meetings and all things are going on. We have to fix the problem actually what exactly happened and see that it's rectified. More importantly, all our missions even if it means with some kind of a small failure or something, we are able to come back and to the original track only because of our strength that we need to analyze exactly what has gone wrong. So he is not able to come because of his own preoccupations on many of the other things, as well as he's away from Bangalore today. So he was so happy to receive this award from you, and I on behalf of him, I thank all of you for judging him for this particular award, prestigious award, and on behalf of him also, I'll wish you all the very best. Thank you. It was an honor to me receive this award on behalf of him also. Okay.
Thank you very much indeed, Dr. P.V. Venkatakrishnan, receiving the award on behalf of Dr. K. Sivan, Chairman, ISRO. Ladies and gentlemen, with that, we've come to the end of the inaugural session. We will have a photo op. I'd like to request all the IESA Executive Council to please join our chief guests on stage. I'd like to once again request our chief guests for this morning to please come back on stage for a photo op. I'd like to invite Dr. P.V. Venkatakrishnan and Dr. A.S. Kiran Kumar to please join the Executive Council members from IESA on stage for a photo op. We'd like to thank you all in the meantime for being a part of the inaugural session. And we'd like to request all of you to be present on both days for the informative sessions by our keynote speakers. We have panel discussions, very interesting panel discussions and sessions by ISRO and DRDO, as well as the very interesting expo of space and defense companies and startups. We also have the ISRO Mobile Museum on display at the event on both days. So once again, we look forward to an engaging partnership and request all of you to please join us for both days. Having said that, before we move into our first keynote, we take a short recess of 15 minutes. Tea and coffee is being served outside. So ladies and gentlemen, refresh yourselves and request you all to please be back and be seated 15 minutes from now for our first keynote by Terry Marin Martineau, Vice President, Engineering and CTO, TE Connectivity. Ladies and gentlemen, as we're about to begin, I'd like to request those who are not seated and attending this keynote session to please take your seats. As courtesy to our speakers, we'd like to once again request you, if you're carrying mobile phones, please ensure that you switch your instruments off or turn them to the silent mode for the duration of the keynote. All right, ladies and gentlemen, welcome back and welcome to our very first keynote for this summit. I'd like to introduce our keynote speaker this morning to all of you. Thierry Marin Martineau is Vice President, Engineering and CTO at TE Connectivity. He is an aerospace engineer with a vast experience in developing systems and applications working in the aviation industry. He has worked on thrust mechanisms of Airbus A380. He has deep knowledge of on electrical braking systems and has drafted a prototype which later was implemented on Boeing 787. Thierry is an inventor and has established a company working on various seat actuators, and almost all planes, I'm told, have deployed them. Thierry has around 39 patents to his name, and on the lighter side, he likes to race and ride motorbikes. Ladies and gentlemen, please welcome on stage Thierry Marine Martinaud.
Thank you. Good morning, everybody. I hope you are not too hungry and you will be patient for the next 30 minutes. So, what about TE connectivity? The best opportunity I have is to share with you a video. Are you sure?
Impossible. For the few, this word is not an endpoint. It's a starting point for tomorrow's breakthrough. For them, no idea is too far-fetched. This endless quest forward by engineers has put the world at the dawn of a golden age of innovation. Today, we're dazzled by technology that didn't exist just a few years ago. Tomorrow is being born before our very eyes. And TE connectivity is at the cusp of this transformation, straddling all that can be done and all that will be done. Our engineers, working with other engineers, custom making the sensors and connectors that lead to new ways of living. Robots responding to human activity, roads talking to cars, the always-on internet, technology revolutionizing healthcare, reshaping industry, redefining the future. Collaboration that's making our world safer, greener, smarter, and more beautiful, turning today's impossible into tomorrow's awesome. TE Connectivity, every connection counts.
So TE Connectivity is a worldwide company, but the message I have for you today is we are local. The approach from TE is to be close to the customer. So we have here in Bangalore a manufacturing workshop. We are also developing a center of excellence of engineering, and we have grown the team a lot last year, and we are doubling these resources for next year. So outside of that, being the world leader in connectivity, TE is also the world leader in innovation. We have been in the top 100 most innovative company for the last 7 years. And last year, we have been in the top 50 most innovative company. So I am personally the CTO of the Aerospace, Defense and Marine business unit from TE. And we are addressing different markets: commercial, space, marine, oil and gas, military. And we have also a wide product range. So we are developing connectors, hermetic connector, high speed, signal power. We are developing wire and harnesses, and also all the components which are part of a power distribution systems. I wanted to share with you today two global technology trends which are driving a lot of our engineering effort, road mapping effort, and we are, with my 400 engineers, in charge of preparing the components which will support your future. So a big trend that we have across all the industries is the demand for more electrical power. So we can see that in the automotive industry. We see that in the commercial aerospace. We are currently seeing electrical system network at 1 megawatt, above 1 megawatt. And in the coming years, we are targeting the 3-5 megawatts. So these trends, as a supplier, we have to read through these customer needs and understand what will be required in the future. So behind this more electrical power, we will have to develop solutions. And unfortunately, all for flying platforms, even on the ground, but more for the flying platform, this increase of power will oblige us to use larger gauge of wires. But we can't afford that. We will bring too much weight for the aircraft. So to manage that, the technical solution is to increase the voltage. So that's why people are sometimes confused. It's the high power which is driving the high voltage. Now, high voltage is not an easy solution. On the ground, it has been used for many years. This is what you have above your heads to carry a lot of current and electrical power. For an aircraft, we have an enemy. It's called the corona effect. So if you go in altitude, the air starts to be conductive, and it creates a lot of problems. So we have to anticipate these problems and develop a generation of connectors and cables which will be corona-less or corona-resistant. Another big trend across the industry is the request for high speed. So one more, we have to translate what does that mean. Why do we want to have more and more speed? Across the industries, we see a request for exchanging more data. There are different reasons for that, but I have given 3 examples here. So in the military area, this picture is representing a new way of, it's a battlefield, but that's close to the reality. Now you have soldiers somewhere in the world, and you have other people somewhere in a bunker far from the battlefield, and they want to see, they want to hear, they want to smell what's going on in this battlefield. So all the soldiers and the platforms you have on the battlefield, you want them to communicate, you want them to see, you want them to measure. You want now to be more and more precise in the information. So you want to have details about the soldier himself. You can measure the physiological parameters of the soldier. You want to know, like in a game, what is the energy remaining in this soldier if he's in a good shape. You want to hear his heart rate. You want to know the level of munitions remaining on these soldiers. And you want to have this vision for all your platform and the means you have in this battlefield, but you want to have the evaluation of your enemy and have a good estimate of what they have also to fine-tune your strategy and being more precise in your actions. So maybe another area which is less dramatic is the picture in the lower right corner. It represents the computer cloud. So why do we need more and more speed in these areas? It's because all of us. So I am looking at you and I am trying to see in each individual's maybe 40 to 100 parameters which define yourself, who you are, how do you drive, where do you drive every day, how you eat, what do you buy. All these data are collected by every suppliers you are using in your private life. You are using a GPS system. They are learning about what you are doing every day. They can recommend you early in the morning, hey, can you confirm you are going to work? Because they know you are going to work. They can propose the place for the restaurant on your way because they know you are used to stop in this restaurant. So all this information which are collected, they have to go somewhere. They have to be stored. What do you do in this computer? You are using AI to analyze all these parameters and define strategy or serve some other suppliers who are looking at this data to know if I want to sell this product, who should I talk to? And I have identified few guys here. I know your address, I know your email, I know your phone number, so I can target you and be successful in my launch because I know that 95% of the case, you will buy my product because I know who you are and I know what you are looking for. So because of that, we need a lot of computation capabilities, and we want to transfer this data in many areas. In the middle is another area which is growing, is all these self-driving autonomous vehicles. And not only on the ground, the flying cars are coming, so I have a few words about that, and you have a picture. I will tell you more about this new bird. But as soon as you remove the human body from a machine, from a vehicle, you have to replace him by a huge number of sensors. You are trying to replace the brain by a lot of sensors. And then mixing all this information, you are trying to act, at least at the level of the human body or better, if possible. So that's why when you are driving, the car has to measure the information about his environment, but because around him, he has a lot of targets which can become a threat in case of somebody is playing with a ball, a kid, or you have other vehicles with an incident and they are changing their trajectory. You have to know how to react. So you will have to exchange a lot of data between the vehicles, and also between the vehicles and some companies who are very interested by the way you drive. For example, your insurance company. Very soon they will insure you. Depending on the way you drive, you will pay differently. Another example of data today, the famous Tesla company, they are electrical car. They are every second taking the information from the car, the way the drivers are using it, to go in their software, computation, changing their algorithm, and download automatically the microprocessor inside the car to improve and prepare the self-driving car. So this continuous exchange of information and data requires more high speed in the electronics. So for us, we have to develop the connector which will be capable of this high speed. So it's a good introduction between me, what I have said, and all of you, because there is a link with the space. And because of this huge exchange of data, one of the main purpose of the satellites is the communication. So it's not the only one, but that's one of them. We want to exchange very quickly all over the world at any time. Anybody should have access to the website or to a machine or to a home or to a friend or a family. So I have listed some projects. It's difficult to update it because it's moving. A lot of these projects, they are a little bit late. There are some difficulties, technical or financial, but it's coming. The sky will be very, very busy. So it should be a very exciting challenges for you, because we will need launchers and we will need solutions to bring these birds in the sky. Some numbers, I won't read everything, but we are talking, depending on the solution and the function, you want to be low orbit or you want to be high orbit, depending of the cone, you will have a different coverage. There is somewhere a race to be first at the right altitude with the right satellites. So that's why there is a lot of competition at the moment, and I heard some of the presenters before talking about the speed. It is important to be there at the right time. There is a real competition to take a part of this space. Some other example with numbers of satellites, it varies depending on the altitude. We are talking about low orbit, about thousands of satellites, which will make the sky very busy, but it's a lot of opportunities, big opportunities for us to bring the right products. We will have, because of these quantities, we know the challenge of the cost to help you to be economically, financially competitive too. Then I have put this picture because when I was young, I have two big pictures in my life if I make a connection with the space. I was in France. It was in the middle of the night. It was in 1969. And my father, I remember, woke me during the night and he said, "Kids, you may not understand, but you are seeing something which is exceptional." And that was the first man on the moon. And the second one, it was SpaceX. The first time I saw the video on my computer, and I see like a magic or like a Hollywood movie, the launcher coming back on the Earth, landing, like it was very easy. That's the two image which I think it will stay always very deep in me. Because I am an engineer, I realize the work behind that, and you are that kind of guys. I have a lot of respect. I feel very humble today. A lot of brains are behind these big projects. Another example, but it's moving now faster and faster. I think, unfortunately, within a couple of years, everybody will do that, and it will be normal. I don't think we will be any more impressed by this landing. But that has an impact on the design of our product. Think about the way we had to design a connector because of the mission, which was a one launch, a one mission. Now we have to change our strategy because we have connectors which will experience high temp, high vibration, but they will experience that many times. So there is behind that, we have to read the story and change the way we develop the product to be sure we will support your dreams. So what do we do to help you? So my job and the job of the 400 engineers working with me is to be sure we are not waiting for the request from you because we will be almost late. The time to develop a new technology could be between 12 months, could be 3 years. So we have to listen to you, and that's why I hope you will take the opportunity to work more and more with our engineers, sales and field application engineers here in Bangalore to talk. That way we can understand what will be your need and we will be able to develop the right product for you. So I will go quick through that. I won't read everything. We have a booth here just on the left when you go out. We have the expert. I am personally here. I love technology. I am passionate by everything which is connected to technique and technology. You can question us. But I want to highlight a few things. When you are working with TE, you can work with us in many areas. The first one, if I make the link with the previous presenters, starting with the brain, I mean the intelligence is in the microprocessor, so the software is loaded there. Then we start working at the board level. TE Connectivity and AD&M, we are the world leader in this high-speed connection on the PCB. We are the leader in we call it the Vita standard for high-speed connector. The name for us is the multi-gig RT3, the latest generation. We are able in a very small pitch with a minimum space on your PCBs to work at 25 gigabit per second, but in harsh environment. So we know the temperature, vibration, shock. And just for your information, within TE, we have solutions which work in the lab up to 126 gigabit. And in the harsh environment, before I left the US, we just finalized the first modelization of what will be the RT4, which is the same, we try to keep the same space on your PCB, same format, the RT4, we will offer you 56 gigabit per second, harsh environment. So that's the latest development. Something, I don't know if you are using a lot in the space industry here, but we see a switch in the industry, hybrid solution between copper and fiber optic. So we have also in the same format developed solution. We have the transceiver solution, so we manage the translation between copper, the electron and the photon, or the photon and the electron in a very, very small space. The latest development, we are able to integrate the transceiver in a size 8 contact. Another area, I think the Deutsch brand name is pretty famous here, and we have different solutions in circular connector. We are already space approved, we can handle a lot of vibration and temperature variation. In material science, we have within TE 80 engineers working on the advanced research, not reporting directly to me. It's a shared resources for TE. They are made, 50% of them, they are PhDs, so they are playing with molecules. They are developing materials, and they can change the mechanical properties, they can change the electrical properties. So playing on the molecules. So we can develop the solution which fits for your needs. A good example is the hermetic connectors. You have some applications somewhere, you need a hermetic connector. So the technology which is well known today is to use glass hermetic, but we have developed also for some space activity, some epoxy. So our glass hermetic connectors, they are currently at 10-9 helium test, and the epoxy is guaranteed up to 10-6 helium leakage. Innovation, so that's really the engine. It's in our DNA, it's in my DNA, it's in the TE DNA, it's trying to bring something in the product. We have collected the information working with customers that in space, we think that commonly we said that there is nothing in space, it's empty, but in fact there are some particles, and you can have sometimes some electrostatic discharge. So we have developed, it's in concept because it's under testing at the moment, using some carbon nanotubes to replace the shielding of the cables. So that could be a huge interest for you. It's the weight saving, and it's the reliability and the availability of your function in space. After sales market in space is pretty costly, so it's better to think about it before. Aluminum cable, I have to mention that the aluminum cable are very well known since many, many years, but for the aerospace application, we had an obstacle. The obstacle was the crimping area, the contact, how to crimp an aluminum contact on a cable. It has to be reliable. So we have developed for the first time on the commercial aircraft, was in 2008 for the Airbus A380. We have developed a contact and qualified a contact compatible with the Airbus spec and the aluminum cable. And now we have a full range of contact for signal and power. Just for your information, for an Airbus A380, the big bird, thanks to the contact we have been able to use cable, it brings a savings of 600 kilos per aircraft. So huge saving in terms of weight. Then around the cable and harnesses, we have the capabilities to develop any specific harnesses with any specific termination, and that can be locally made. We have the workshop here in Bangalore. We are also thinking about cost impact in your production, so we are working always on fast installation. We have recently launched, we call it the P clamp. It's a simple bracket, but you can operate it with one hand, and it has a double safety for the locking mechanism, which is required for most of the aerospace application. So you can have this bracket pre-positioned on your platform. You develop your harness and close the bracket first time just by the hand, and then you can come back and you have a locking mechanism, so you have a double safety. The other one is just the imagination on very simple product like a tie wrap. In the commercial application, at least, harnesses are using tie wrap, but this small head that you have on the tie wrap could be an enemy when you are trying to install it. It always stays stuck somewhere against the structure or damage something. So we have developed the T wrap, which is a flat head, and as you can see on the picture, is very smooth. Within AD&M, we have also the widest range of product for power distribution under the brand name of Kilovac and Hartmann. We are ready for the high voltage. We have already a product range of 1000 volt, 1000 amp. We have developed also pioneer in the solid state relay, which is also very reliable system, so you don't need any more electromechanical actuation. It's made electronically. We have developed a 270 volt, 600 amp, and we are working 300 amp, and we are working on the 600 amp version, so high power solid state solution. And also TE is maybe not known enough. We are the world leader in sensors. So we have the full range of sensors. Most of them are mainly dedicated to automotive application, but we have some extension and reuse of these sensors in many, many areas. So if you have a need for a sensors, you can contact us. We may have the product already on the shelf, or we may modify an existing product to make it, to ruggedize it for your application. As I said, you heard a few messages about me. I am an innovator, 39 patents or ish, something like that. And I am a fan of, I am racing motorcycle. So somewhere outside of TE, I am the TE champion. I volunteered. I am part of a team which is called R-Loop. So we have developed the mock-up of, we were part of the Hyperloop competition organized by Elon Musk. And then with this team, we are now on a Boeing contest called Go Fly. And TE is a sponsor of this team, as I am a member also of the team. And we have developed the orange vehicle, which is called the R-Flight. So it's a vertical takeoff. And I just wanted to share with you my passion for that. So I try to stay young. I try to stay aware. I am learning a lot because these teams, we are spread all over the world. So we are working with collaborative tools. We never met. We don't know each other just through the Google application. It's very interesting from a human point of view. So I am very interested to understand the mechanism of the passion, the motivation. And I am trying to think about how can I bring that at home and get the same passion. It's very interesting. So I am sharing with you just a video. I think I have to launch it. Yeah.
We're here to change the way the world looks at the sky.
It's a truly inspiring challenge to solve. To fly a single man vehicle for 20 minutes without refueling or recharging. Because the tech is advancing and the cost is coming down, anybody with a smartphone or a laptop or a computer can connect with anybody around the world, find someone who's got the shared passion and interest, and there's nothing really restricting you from doing what you want to do. We've already overcome our own borders and boundaries to connect and work together. Coming from all different parts of the world, but we're all here for the same reason.
So people will look up and see the same thing we do, an opportunity.
TE connectivity has always pushed the boundary of engineering, innovation, and mobility. We are inspired by and are determined to support the possibilities of air flight, be it providing disaster relief in remote areas to being able to take to the skies with the same freedom and thrill of a motorcycle.
There's no instruction manual, but at least we have all the parts.
We are proud to connect with teams like Airflight. We are making the world a more innovative place. Because at TE Connectivity, every connection counts. Okay. Thank you.
Ladies and gentlemen, please give him a big round of applause once again. Thierry Marin Martinot, I would like to request Sanjeev Keskar from Managing Director Aero Electronics to present a small token of our appreciation to Terry on behalf of IESA. We'd like to thank you once again for that keynote address, the very first one for this summit.